Hi everybody, it's Professor Mitchell. We are continuing with Chapter 1 on functions and graphs, and today we're going to talk about linear functions and slope. So I mentioned at the end of the last video that I do not cover this section in trigonometry, but you've probably seen just about all of this stuff in an algebra class. So in this section, we're going to calculate a line slope, write the point-slope form of the equation of a line, write and graph the slope-intercept form of the equation of a line, graph horizontal or vertical lines, recognize and use the general form of a line's equation, use intercepts to graph the general form of a line's equation, and finally model data with linear functions and make predictions. Starting with slope, remember that the slope of a line through the distinct points x1, y1, and x2, y2 is given by this formula. You can think of it as the change in y over the change in x, or the rise over the run, and it's y2 minus y1 over x2 minus x1, the difference in the y's divided by the difference in the x's. And of course, for that expression to make sense, x2 minus x1 cannot equal 0 because you're not allowed to divide by 0. So for example, to find the slope of the line passing through the points 4, -2 and -1, 5, we would use that formula. I always recommend labeling your points. It's easy to put numbers in the wrong place when you're using this formula. So for example, label this x1, y1, and label the other point x2, y2. It doesn't matter which point is x1, y1, and which point is x2, y2, as long as you don't put x2 with y1 or put x1 with y2. So if you do that, you get 5 minus -2 divided by -1 minus 4, which comes out to 7 over -5, or -7/5. All right. Next, we have point-slope form. This comes from the slope formula. The point-slope form of the equation of a non-vertical line with slope m that passes through the point x1, y1 is given by the formula y minus y1 equals m times x minus x1. So for example, to write an equation in point-slope form for the line with slope 6 that passes through the point 2, -5, we would take our point-slope formula, and I'm replacing m with 6. Remember, m is the slope. Replacing x1 with 2, replacing y1 with -5. Be careful with the minus signs. This formula has a couple of built-in minus signs. And when you simplify that equation, you get y plus 5 equals 6 times x minus 2. So when they ask for the equation in point-slope form, usually they want you to take it this far, but they're actually asking me to solve the equation for y. So I'm going to distribute the 6, and then I'm going to subtract 5 on both sides, and that's going to give me y equals 6x minus 17. All right, and that form of the equation of a line is actually called the slope-intercept form. The slope-intercept form of the equation of a non-vertical line with slope m and y-intercept b is y equals mx plus b. All right, so to graph a line whose equation is in slope-intercept form, the easiest thing to do is to start by plotting the y-intercept, which is the point 0, b, and then obtain a second point using the slope m. Write m as a fraction and use rise over run, starting at the point containing the y-intercept to plot that second point, and then use a straight edge to draw a line through the 2 points. Draw arrowheads at the ends of the line to show that the line continues indefinitely in both directions. All right, so for example, to graph the linear function f of x equals 3/5 x plus 1, we would start by plotting the point 0, 1. And then, starting from the point 0, 1, we're going to rise 3 and run 5 because the slope is 3/5. So that brings us to the point 4, 5. And now we will draw our line through those 2 points. That brings us to horizontal lines. A horizontal line is given by an equation of the form y equals b, where b is the y-intercept of the line. Remember that the slope of a horizontal line is 0. I'm hoping that every single thing we've talked about so far in this section is review. Vertical lines are given by an equation of the form x equals a, where a is the x-intercept of the line. Remember that the slope of a vertical line is undefined. Vertical line is the only kind of line that does not have a defined slope. So to graph y equals 3 in the rectangular coordinate system, you can start at the point 0, 3 and then just draw a horizontal line in both directions. Every line, even vertical lines, have equations that can be written in the general form ax plus by plus c equals 0, where a, b, and c are real numbers, and a and b are not both 0. One of them can be 0. If one of a or b is 0, that means you have either a horizontal or a vertical line. All right, so in this example, we're going to find the slope and y-intercept of the line whose equation is 3x plus 6y minus 12 equals 0. So the easiest way to do that is to just solve this equation for y. And then we'll have it in slope-intercept form. We can read off the slope and the y-intercept. All right, so what they've done is subtracted 3x from both sides and then added 12 to both sides. That brings us here. And then divide everybody by 6. 6 divided by 6 is 1. Negative 3/6 simplifies to negative 1/2. 12 divided by 6 is 2. This is now in the form y equals mx plus b. The slope is negative 1/2 and the y-intercept is 2. You can also use intercepts to graph a line whose equation is in this form. Sometimes I encourage doing it that way. So first find the y-intercept by setting, find the x-intercept by setting y equal to 0 and solving for x. Plot the point containing the x-intercept on the x-axis. And then similarly, find the y-intercept. Let x equal 0 and solve for y. Plot the point containing the y-intercept on the y-axis. Okay, and then we'll use a straight edge to draw a line through those 2 points. And of course, we'll draw arrowheads at the ends of the line to show that the line continues infinitely in both directions. Okay. So to graph this line using the intercepts, 3x minus 2y minus 6 equals 0. First, we'll find the x-intercept by setting y equal to 0. That's going to give us 3x minus 6 equals 0, which means x equals 2. So that's talking about the point 2, 0. And then we'll find the y-intercept by setting x equal to 0. That's going to give us negative 2y minus 6 equals 0. Add 6 to both sides, you get negative 2y equals 6, which means y is negative 3. So now we're talking about the point 0, negative 3. So this line passes through 2, 0, and 0, negative 3. So we've drawn the line going through those 2 points. All right, and we'll end this section by looking at an application. Use the data points 3, 17, 57.04, and 354, 57.64 to obtain a linear function that models average global temperature, f of x, for an atmospheric carbon dioxide concentration of x parts per million. And they're telling me to round m to 3 decimal places and round b to 1 decimal place. So the moral of the story here is they're saying that as the concentration of carbon dioxide in the atmosphere goes up, so does the average global temperature. So first we'll find the slope, the change in y over the change in x. So again, I recommend labeling those 2 points. This is x1, y1, that's x2, y2. 57.64 minus 57.04 divided by 354 minus 317 gives me 0.6 divided by 37, which is approximately 0.016. And then I'll use the point slope formula to find the equation of the line. The slope is 0.016, and they're using the second point, it looks like. You can use either one of those points. Distributing 0.016, you get 0.016x minus 5.664. And then when you add 57.64 to both sides, you get y equals 0.016x plus 51.976. So the function that gives you the average global temperature as a function of the concentration of carbon dioxide is f of x equals 0.016x plus 52.0. Remember, they said to round this one to 1 decimal place. And that's going to do it for section 1.4. We'll see you next time.